arkadaşlar. So today I want to go over this main formulation. If you remember, like h of z is h of n, z to the power minus n, n from minus infinity to plus infinity. If you remember, that was our z transform formulation. And x of n is our discrete time signal. H of z is my z transform, okay? There were two things I want you to be aware of. First, I'm gonna perform this transformation, and then at the same time, I need to be careful about ROC. ROC was region of convergence. Why is region of convergence critical? If you remember, I told you that if, for example, if I'm working with Fourier transform, and if I have h of n again, e to the power minus j omega n from infinity to plus, from minus infinity to plus infinity, this is only possible to obtain the Fourier transform of its sequence or a signal when h of n is it should be less than infinity, so finite we mean, okay? So this thing should be finite. The addition of these h of n's should be finite. I need to have such a let's say I need to have a 1/2 to the power n un type of thing. I cannot find the Fourier transform of this signal, okay? It's not possible to find like divergent signals Fourier transform. You are with me, right, arkadaşlar? You remember these things? That's why we need a more general understanding, a more general methodology to work with. Actually, Laplace transform is the continuous time version of Z transform. And instead of S in Laplace transform, we were using S instead of j omega. Here we are going to use Z instead of e to the j omega. Okay, so I want you to understand this concept. But Z is a little bit much more general in terms of this radius of your e to the j omega can change, can expand or squeeze. Okay, so it can go up and down. E to the j omega is only like unit circle, but when I have r times e to the j omega, then my r, according to my r, my radius of the circle will change as we want. Okay, so let me start. Let me remind you one thing here. 1/2 to the power n un was like I was finding from n from 0 to infinity 1/2 to the power n z to the power minus n, and then I was writing 1/2 z to the power n to the power n from 0 to, this was alpha, and this is like 1 minus alpha, which is 1 divided by 1 minus 1/2 z to the power minus 1, and alpha was less than 1, so 1/2 z to the 1/2 z to the power 1 is less than 1. Okay, this is something that we have done last week. I don't want to go into detail, but I want you to remember this is how we deal with everything. Okay, we take the formulation, we put our sequence in place, then we say that, okay, I'm going to do as if my alpha is less than 1, and then perform the infinite series summation. And then finally, I say, okay, this alpha should be less than 1. That's why I need to come up with a ROC curve for this infinite sum to converge to a value. Okay, that was the main idea, if you remember. Hatırlıyor muyuz buralar arkadaşlar? Do you remember these kind of things? I'm going to do some more exercises, and I hope you understand my explanations. Bakın arkadaşlar, if I have 1/2 to the power n un, its z transform is going to be 1 minus 1/2 z to the power minus 1. Okay, if you remember, like 1 over 2 to the power n un, its Fourier transform was what? 1 over 1 minus 1 over 2 e to the power j omega, right? Instead of this, we put z to the power minus 1. Same kind of approach. But what should we say? Z should be, okay, greater than 1 over 2. How did I say that? I looked at this one. 1 over 2 z less than 1. Okay, I'm going to take this one here, and then z is going to be greater than 1 over 2. Arkadaşlar, this type of a sequence is called right-sided sequence. Sağ yönlü, right-sided sequence. Okay, this is right-sided sequence. Sağ yönlü. Okay, I'm gonna work with one left-sided sequence right now. Do you have any questions at this point, arkadaşlar? This is a kind of wrap up of the last week. I want to jump into new topics right now. If you remember, we had such things, we had such signals, arkadaşlar. For example, b to the power n minus 1. Can you draw such a signal, arkadaşlar? Can you draw such a signal or a sequence? It depends on b, right? If b is greater than 1, it will be something like that. Is that correct, arkadaşlar? For example, if b is equal to 2, this is 1 over 2, 1 over 4, 1 over 8, 1 over 16. Okay? Actually, it should be like this. You're gonna, at the end, you're gonna understand why I put this minus sign here, okay? So this is a left-sided sequence. Left-sided. It goes to minus infinity. The previous one was going to plus infinity. This one is going to minus infinity, okay? You understand the difference between left-sided and right-sided, right? This is minus infinity part. And if I want to draw this one, 1 over 2, 1 over 4, and so on. And this is going to be 0, 1, 2, 3. This is right-sided, going towards plus infinity. Anladık mı gençler burasını? Peki, let's work on this one. I want to work on this one together. Şimdi, how are you going to write this? X of z is equal to minus b to the power n u minus n minus 1 z to the power minus n. Okay, I want everybody to be able to write this in the initial phase, okay? You can write it, right? What is the next, what's the next step? Changing my boundaries. What is the boundary? Ahmet Özsan, what is the boundary?
Minus 1 to minus infinity.
From minus infinity to minus 1, right? Thank you very much. So I will keep, now I don't need this anymore, okay? Because it is already in my formulation. B z minus 1 to the power n. Now I got rid of this part. I put b to the power n, z to the power minus n.
Hocam, is that -1 or 1?
Which one?
The boundary, upper boundary.
It should be -1, Süleyman. Why? Because how do I do it? -1 minus n minus 1 should be greater than 0, right? Should be greater than or equal to 0. So how should I write? -n will be this, and n should be less than -1.
I got it, hocam. Thank you.
Okay, so it should always be less than -1, left-sided.
Okay.
Okay. Are you with me, guys, in terms of this part? Yes. Now this is my alpha. This is my alpha. I'm gonna assume that alpha is less than 1. Okay, but not now. Let me do some changes. How should I start my boundary changes, arkadaşlar? Is this okay? I just write n, instead of n, I just write -n. So my boundaries will go from, not from -infinity, but to +infinity. Okay? Or I would do such a thing, m is equal to -n. Then this will be like when I see n, I will put -m. When I see n, I will put -m. Okay, so it's the same thing. Either I will do this, or I will write, instead of n, I will write -n in order to change this into this. Do you understand this part, arkadaşlar? Is everything clear here? Yes. It is also critical for you to understand this when you're doing Fourier transform similarly, right? So what should I do next? If you remember, my formulation was n from 0 to infinity alpha to the power n is equal to 1 minus alpha. 1 over 1 minus alpha. How should I arrange my formulation in such a way that I will go from here and make it similar to this one? What should I do, arkadaşlar? I should first take this minus inside. Alper, sana soracağım şimdi. Now I'm writing it -n. N is equal to from 1 to infinity. B to the power -1, Z to the power n. Why am I doing this? Because I need something like this one. Alpha to the power n, because I know the result of that infinite sum. It is 1 over 1 minus alpha. That's why I'm changing this -n stuff into n. Anlaşıldı değil mi arkadaşlar? So now I have, but I don't have 0 right now. I have 1. How should I deal with this problem? How I deal with this, arkadaşlar, like this? Minus
M equals n minus 1.
It's also possible. I do it like this. Bakın bunu da görmüş olun. From n 0 to infinity. Let's say this is alpha. Alpha to the power n minus n equals 0 to 0. Alpha to the power n. What did I do? I added all the terms from 0 to infinity, then subtracted the 0th term so that I'm left with terms starting from 1 to infinity. Understand, arkadaşlar? Now here I have 0, 1, 2, 3, 4, 5. Here I'm saying 0 is gone. What I'm left with? I'm left with 1 to infinity then. What is n equals 0 thing? Alpha to the power 0. What is it? Alpha to the power 0.
1.
This part is going to be 1. Right? So I'm going to rearrange my formulation right now. It is going to be equal to minus n equals 0 to infinity b to the power minus 1 z n minus 1. Is that okay arkadaşlar? Yes. So what is the result of this first part? One over 1 minus b to the power minus 1 z. I'm going to write this multiply by minus 1, 1 minus. Are you with me, guys? Did you understand this part? Yes? It's going to be equal to 1 minus b to the power minus 1 z minus 1 divided by 1 minus b to the power 1 z, which is equal to minus b to the power minus 1 z divided by 1 minus b to the power minus 1 z. Is that okay arkadaşlar? Yes. Let me go one step further. It's equal to, if I multiply both sides by minus, if I multiply both sides by minus b, what will I have? Arkadaşlar, Süleyman, what is the answer? If I multiply both sides by minus b,
E over
Z
minus
over
b minus 1.
is this correct? Z over z, z over z minus b. Is this correct arkadaşlar?
That's correct.
Yes. If I go one step further and divide both sides by z, what do I have? 1 over
1 minus
1 minus b z to the power minus 1. You get me, right, arkadaşlar? So all of these are z transforms. This one, or this one. But all of them are z transforms. But mainly we will use this one because it is going to be a lot easy for us to deal with. Okay? Bakın arkadaşlar, güzel kardeşlerim. B to the power n un. What was the z transform of b to the power n un? 1 over 1 minus b z to the power minus 1. You see they are the same. What was this case? Minus b to the power n u minus n minus 1. Same thing. This one is right-sided sequence. This one is left-sided sequence. They have the same z transform, but what is different in them? Here, z is greater than b, right? Z is greater than b. If you remember, our formulation is like this one, and alpha is this, and alpha is equal to b z minus 1, and is less than 1. So b divided by z is less than 1, z should be greater than b. But here, what is my z transform? I should go back and work on this one. B to the power minus 1 z is going to be less than 1. So z divided by b is less than 1. Z should be less than b. So if I'm working with right-sided sequences, then my region of convergence will be z, absolute z will be greater than b. If I'm working with left-sided sequence, then I would be saying that my ROC will be absolute z less than b. One of them is greater than b, right-sided. The other one is less than b, left-sided. Okay? Here is b, left-sided, right-sided. Okay? Greater than b, less than b. We will use this in coming part of this session. Okay? So that's why I want you to understand this part. Is everybody with me right now, arkadaşlar? Do you understand this concept? B to the power n. Let me ask one easy question then. If you understand this concept, I want you to now. I'm gonna give you some time for that. Evet, 7 times 1 over 3 to the power n un minus 6 1 over 2 n un. What I want you to do is x of z is what? And I want you to find out and plot. Find and plot ROC. Plot means I've shown you some things, but I want you to first focus on this part. Evet, please write to the chat in a private manner. Arkadaşlar, can you tell me what the ROC of this part?
Absolute z must bigger than 1 over 3.
Absolute z should be greater than 1 over 3. How about this part, Doğan? Absolute z should be
greater than 1 over 2.
1 over 2, değil mi? So I have two ROCs right now. Bakın, how do I deal with ROC stuff right now? Let me tell you. Now I drove my ROC. How do I draw it? One of them is 1 over 2. Okay. Let's say this is 1 over 2. The other one is 1 over 3. Okay. Then both are right-sided. Right-sided means going up. Okay. The radiation is going up. So 1 over 3. Let's say this is 1 over 2, 1 over 3. And the other one, this one, is going to be here. So the intersection of these two things will be what? What is the intersection of these two? Z being greater than?
1 over 2.
1 over 2, right? So arkadaşlar, this is my ROC plots writing as a formulation. This is my plot, okay? This is the real part. This is the imaginary part. And I'm only interested in the places or the z-plane, complex plane, which is greater than 1 over 2. Anlıyor muyuz burayı? So I'm gonna do something else in which we will have one right-sided, one left-sided sequence. Okay? So, şimdi let's go one step further. I'm gonna do some calculations. What did I do at this point? Equalization of the denominators, right? Paydaların eşitlenmesi, equalization of the denominators. I multiplied this with this one. I multiplied this with this one. So what is left? What is left? 1 minus 3 over 2 z to the power minus 1 divided by the multiplication of these two.
I'm sorry, Hocam, can you explain again? I lost my internet for a minute here.
Sure. This is how I found my right-sided sequences Z transforms. I hope you understand this part, right? Going from
Yes.
here to there. Then I equalized the denominators. I multiplied this with this one, and I'll multiply this with this one, and subtracted from each other. Okay. And then the bottom parts are now equal to each other.
Yeah.
Okay. Then what did I do? 7 minus 7 over 2 z to the power minus 1. 6 minus 6 plus 2 z to the power minus 1. Now 7 minus 6 is 1. 3.5, 2, I would have 1.5 minus 1.5 or 3 over 2 z to the power minus 1.
Yeah.
Is that clear, Yasir?
Yeah, Hocam, thank you so
Okay.
much.
Şimdi I am about to, I'm done with my Z transform calculations. Now I want to talk about two new terms which are called pole zero. Pole zero. Okay. Now I have my Z transform like that. Let me write once more here. 1 minus 3 over 2 z minus 1 divided by 1 minus 1 over 3 z to the power minus 1. 1 minus 1 over 2 z to the power minus 1. Okay. This is x of z. Now, if you are asked in a question, give me the ROC curve, ROC, and then plot the ROC and indicate the poles and zeros on the ROC. What does pole and zero mean? Here's the definition. Arkadaşlar, the z values that are making this x of z to 0 is called z, 0. Okay? X, z being equal to 0, for these z's we call them zeros. For z's making this go to infinity, then we call them poles. Okay? How do I find zeros and poles? Here is how we do it. Bakın, how many z to the power minus 1s I have? 2. I'm going to multiply both sides by z to the power 2. Z squared 1 minus 3 over 2 z minus 1 divided by z times 1 minus times z I'm trying to make it more easy for me to find zeros and poles by doing this multiplications by z square. Arkadaşlar, let me start from an easy thing, like 1 over 1 minus 1 over 2 z to the power minus 1. How do I find the pole and zero? Can you tell me what x of n, if I know that this is my x of z? Can you immediately tell me what x of n is?
1 over 2 n un.
1 over 2 to the power n un, right?
Yes.
Okay, so how do I find the pole and zero?
Multiplied by z both.
Multiply by z, right? Neden? Çünkü I have 1 z to the power minus 1. Multiply both sides by z, and I'm going to have z over z minus 1, z minus 1 over 2. Which z value makes this x of z equal to 0? Z equals 0, right? X of z being equal to 0, then output will be 0. So this is my 0. How about the pole? For the pole, I'm looking at this part. And z equals 1 over 2 will be my pole. Why? Because when z is equal to 1 over 2, it's going to be z divided by 0, which will converge to plus infinity.
Infinity.
Okay? So that's why I should plot my ROC like this. What did I say? Z should be greater than 1 over 2. That's why I'm making it dotted line. It's not included. It's not like this. It is like that. Okay? It's not equal, greater than or equal to. It is only greater than. So nasıl devam ediyorum şimdi? I'm gonna put a cross çarpı to the pole and 1 0 or circle to the 0 part. Anlıyor muyuz? And then I'm gonna put my sunlight's radiation like this. This is imaginary z. This is real z. Do you understand what I'm doing, arkadaşlar? So this part is this z greater than 1 over 2. And pole is here. 0 is here. Okay, for one right-sided sequence, it's the case. You understand what I'm doing, arkadaşlar? Let me come back and solve this one right now. Where are my poles? I'm going to find out here. Z times z minus 3 over 2 divided by z minus 1 over 3, z minus 1 over 2. Is this part clear, arkadaşlar?
Hocam, why we multiplied with z square, not just z?
Let us try it, Nurefşan, and see if you multiply by only z. Z times 1 minus 3 over 2 z to the power minus 1 divided by z 1 minus 1 over 3 . What will this part do? Z minus 3 over 2. I'm going to find the 0 here. But here, now I have z minus 1 over 3. Here I have 1 minus 1 over 2 z to the power minus 1. So I have still z to the power minus 1. I don't want to deal with z to the power minus 1. So I want to deal with z. That's why it's like a polynomial stuff, okay? Now my polynomials are z to the power minus 1. I'm converting them into z-type polynomials so that I can find the roots of that polynomial. Anlıyor muyuz? So that's why if I have 2z to the power minus 1s, then I multiply by z squared so that it will become like this, z times z minus something times z minus something. Now these are my roots of my polynomial. Anlıyor muyuz? So what are the zeros of this x of z?
0
Kürşat?
and
0 and
0 and 3 over 2.
Z equals 0, z equals
kuş.
3 over 2.
3 over 2. How about poles? Anye?
Poles will be 1 over 3 and
1 over
2.
3,
1 over 2.
1 over 2. Now, can I draw my pole 0 and ROC stuff here? This is real. This is imaginary z. I have two sequences. I have two sequences here, both right-sided sequences. And our z's are greater than 1 over 3, greater than 1 over 2. Now I'm going to have 1 over 3, 1 over 2. Both are to the right side. And my zeros are here. Everybody understand what I'm doing here, arkadaşlar? Easy, right? You understand what's going on?
Yeah.
Yes?
Yeah. Hocam, what are these poles and zeros? What do they mean? Like,
Good question. Şimdi, for example, we will have, actually, what is z? Z is r times e to the power j omega. Okay? So, at certain z values, our x of z will go to infinity, which we don't want, whose absolute value will go to infinity. Okay, if you think about some filters, for example, if you think about filters, we are trying to come up with such designs of filters, and those filters will give us 0 amplitude for certain frequencies, let's say bigger amplitudes for other frequencies. Okay, so during the calculations, if you remember, you have obtained in your projects, arkadaşlar, you have obtained something like that, for example, in Butterworth filters or Chebyshev filters or elliptic filters. Why is this happening like that? Actually, these are our 0 points where my filter's magnitude response becomes 0. Okay? At which omega values my magnitude response goes to 0 means 0. Anlıyor muyuz arkadaşlar? So for certain z values or omega, certain frequencies, if it goes to infinity, then those z values will let's say I won't have any magnitude over there. The magnitude will go to infinity. Okay, I have to be careful while designing my filter by being careful about these poles and zeros. I will give you more info or more insight when we come to the filter design just after we are done with Z transform right now, okay? So if I change the pole, my magnitude response of the filter will change. And I will adjust my pole and zero in such a way that if I adjust it, it will be like a low pass filter. If I adjust it like something else, it will be acting like a band pass filter. Okay, so by adjusting poles and zeros, we will be designing our filters actually. And inshallah, I will spend some time on this changing Z effect on our let's say magnitude responses. Okay.
Hocam.
So, thank you for asking. This is really critical, especially in terms of system analysis, system design, at which Z value, at which frequencies will my system explode? Bakın, pole means my system will explode over there. My X of Z will go to infinity. Patlıyor oralarda. Okay, I don't want to be closer to those points. I should know which, what kind of a filter I have, what kind of a system I have, right? So, for example, you will be dealing with H of Z, which is the transfer function, and we will be coming up with the X of H of Z from Y of N is equal to, let's say, X of N minus X of N minus 1, okay? We will find out the Z transform of this system and then plot our graphs accordingly, find the, let's say, poles and zeros. For example, we will have this IIR filters like this one. Okay, this is an IIR filter. I will talk about FIR and IIR filters. This is an FIR filter. This is an IIR filter. You use them in your projects, but you don't know what they are. And I hope I will be expanding your understanding about FIR and IIR filters. IIR includes previous outputs in the calculation of the new input, new output. It has a recursion feedback loop. Okay, FIR doesn't include such a recursion. It's just like uses the inputs. FIR uses only the inputs in the calculation of the output, the current output. But IIR filters use, or IIR filters, let's say, o zaman uses olmayacak, use both the previous and current inputs and previous outputs, like this one, the previous output. So it becomes like a recursion in your calculations, in your, let's say, filters. Then you will use such a recursion, which will give you a better filter. Okay, it will give you a sharper filter with lower orders. Okay, I want you to understand this part for now, and we will continue in more discussions in more detail in the next week, inshallah. Okay, let's have a short break, and then I want to do some more exercises, arkadaşlar. Are you ready, or do you want to stop here? Like, I want to do some more exercises with you together. If you are interested in this we will continue for another half an hour. I want to do some more exercises, okay? Let's have a 5-minute break. We will meet at 11:20, okay, 6-minute break.